Good day, everyone. I hope that you are feeling great today because you have received the blessings of the Lord. So, this morning or this day, let me have this recorded video for your topic for this week. Um, Let me explain the content of your module for for your additional information about it. All right. So before we proceed, let's have a short prayer so that we can receive the blessings and wisdom from above. Let's pray. Dear Heavenly Father, thank you so much once again for this day. May it be, dear Lord, that your presence will be in our midst so that as I explain this to my STEM students in grade 12, they will be able to understand the importance of this lesson in their strand, and it will be a great help as they proceed to their college years. Help me, dear Lord, and we thank you so much for your great love to each one of us. Thank you so much, dear Lord, for everything. This all I ask in Jesus' name. I pray. Amen. So I hope that you are ready as you watch and learn this video. So let me share my screen about your module. All right. So this is the module number 4 for this second semester, and it is entitled Energy in Transit, Chapter 3. All right. And we will focus on the lesson number 3 about thermochemistry. I know that some of you have already encountered this, but we will continue to understand the important information about this topic. All right. So you need to finish this and upload the answer, your file on February 14th. No, it's Valentine's Day, so you will send your file with answer on this day. All right, in your Moodle account. So we have learning competencies. We have three. Explain the first law of thermodynamics. So what's the relationship of thermochemistry and thermodynamics? And then explain enthalpy of a reaction. So what do we mean by enthalpy? All right. And then calculate the change in enthalpy of a given reaction using Hess's law, okay, or Hess law. So we will be defining the definitions of this following terms before we proceed to the main topic, okay, of this module. All right, let's begin. So for the engaged part, using the given picture below, explain the relationship of the words inside the box. So you can refer your answer on pages 56 to 57 of your book. Excuse me. The first one is thermochemistry versus thermodynamics. All right. System versus surroundings. Heat versus work. Exothermic versus endothermic. So you can define first their definition, their meanings, before you will explain their relationship with each other. All right. So next is explore. All right. So explain the first law of thermodynamics. So what's the first law for this thermodynamics? And then letter C, write the meaning of each symbol in the given equation below based on the relationship of heat and work. So this is the first law of thermodynamics, the relationship of heat and work in the chemical reaction, the changes of energy of the chemical reaction. So heat and work, the relationship of heat and work. So they have interrelationship with each other. So you need to familiarize this symbol. So what is the meaning of delta E system equals negative delta E surroundings. Okay, and then so the equation or the formula for delta E system. So the change in um, energy of the system. So what is this system? So you will be learning that later. So the Q is symbolized as heat, and then W is for work. All right. And then negative W, what is the meaning of that versus positive W, or negative work divided by positive work. And then positive heat versus negative heat. All right. Yeah. Letter D, capital letter D, answer the following problems about the relationship of heat and work. You can study the sample problem on page 60. All right. So the letter A, so you will have to answer this simple problem about the relationship of heat and work um, in the changes of the heat in the system. Okay, so what is the work done by a system when it absorbs 47 joules of heat and gain 12 joules of energy? So um, you can use this formula, the one that I highlighted. You just have to identify if the work is negative or positive, or um, the heat is negative or positive. But the question here is, what is the work done by a system? So you just have to um, derive the equation. Okay, so you can refer on sample problem on page 60 for additional information for this one. Okay, so all of the questions that I have put on the engage and explore parts will be uh, will be seen. Okay, the answers will be seen here in the explanation part. Okay, so all the meanings of the terms that I have given above will be you will be able to read here in the explain part. So you just have to be to give time for this, um, so that you can understand every term that I have put here in this module. All right. So I will not be reading this anymore because I have to focus on the um, equation of the enthalpy. Okay, because that's the most important for this module. All right. So you can have um, your own time to understand these definitions, but I will focus on the enthalpy, and then endothermic, and then exothermic. All right, so let me find first the definition of enthalpy, or let me just read in the um, on your book. All right, so page 64. Okay, on page 64, enthalpy is the amount of heat absorbed or released by a chemical reaction at constant atmospheric pressure. So enthalpy is the um, amount of heat absorbed or released by a chemical reaction with with a constant atmospheric pressure. All right. So we will focus here the energy changes of a chemical reaction. Okay, so what's the difference between endothermic and then exothermic? Okay, so let me read the definition. All right, and so endothermic or endothermic, when the system absorbs heat from the surroundings. Okay, so when an object received heat, okay, from the surroundings. I have given here one example. So the melting of ice. So the ice will not melt if it will not absorb the heat. Okay, so endo, it means that you will absorb heat from the surroundings. So the system. So the system in the example is the ice. Okay, so the heat from the surroundings uh, will be uh, the medium, so that the ice will melt. All right. And then exothermic is from the word ex, okay, exo, okay, exothermic. Ibig sabihin, or it means that the heat will be released. Okay, so when the system released heat to the surroundings. Okay, so the example is combustion of gasoline, or all the examples that are belong to the combustion. Okay, so the heat will be released by the system. So that is the definition of exothermic. So you need to understand the definitions or the differences of these two words. Okay, so let's begin. Yeah. So just remember that for you to understand every equation in this topic, you need to really give time to familiarize them. Okay, so next, ayan, the equation, ayan, I've already told this a while ago, so I don't have to explain this anymore. And so you just have to read this. Ayan. So I have emphasized here, let's give time to study the next subtopic. All right, so let's proceed to the next subtopic, which is about enthalpy of a chemical reaction. So we will focus our video in the enthalpy. So what's the definition again of enthalpy? It is the amount of heat. Okay, amount of heat, absorb. Okay, pag absorb, endo. Okay, or release, so exo, of a chemical reaction. And then the atmospheric pressure is constant. Okay, so the changes will just happen in the amount of heat by absorbing or by releasing. Okay, so thermochemical equation, yan, is a chemical equation that shows the value and direction of heat involved in a reaction. So um, you know the chemical equation, right? So in chemical equation, there is a product and then reactant. All right, so in thermochemical equation, it includes the amount of heat, all right, the amount of heat absorbed or released. All right, and then enthalpy, it symbolizes as capital H, is the amount of heat absorbed or released by a chemical reaction at constant atmospheric pressure. Okay, and then the enthalpy H, I mean delta H, all right? So delta H is the enthalpy of reaction. It means there is already a change in chemical reaction. So please remember that the enthalpy of reaction is the difference, okay? Please give emphasis on the one that I highlighted. It is the difference between the enthalpy of the products and the reactants. So always remember that in a chemical reaction, there are two parts, okay? The products and the reactants, okay? So it is the difference between the enthalpy of the products and the reactants. So you will subtract, okay, the enthalpy of the products and the reactants for you to get the enthalpy of reaction. Okay, it says here when the delta H, or the enthalpy of reaction, is positive, the answer is positive, the chemical reaction is endothermic, which means the heat is being absorbed by the system. All right, but when the delta H is negative, the reaction is exothermic. Okay, so please remember that that phrase. Okay, when the enthalpy of reaction is positive, so it means it is endothermic. Okay, but if it's negative, uh, the enthalpy of reaction is exothermic. So we have here the relationship of the chemical equation, thermochemical equation. So delta H, okay, which means enthalpy of reaction equals H sub products minus H sub reactants. Okay, so the total of the products, okay, and then the total of the reactants, you subtract it, and then you will get the amount of heat of the enthalpy of reaction of that certain compound that react with each other. Okay, so it says here also that enthalpy is also extensive property. What does it mean? Extensive. Okay. Its magnitude is proportional to the amount of reactants and products in a reaction. So when the reactants or you have added um, reactants, so the reaction um, will also have a high result. Okay, so proportion. Okay, they are proportional with each other. So we have here an example. um, the other content of this module is can be found in your book, so you just have time to read those. Okay, so let us study the example here that you can also found in your book. It says here, if the amounts of the reactants and products in a thermochemical equation is multiplied by 2. So please, when you encounter a problem about enthalpy of a reaction, please remember if it's multiplied by 2, or if it will be multiplied by 1/2, or it will not be divided at all or multiplied by all. Okay, so it says here that we have here the original equation. Please look at the picture. Yeah, all right. So we have here original equation. Okay. So CH4 is the methane plus um, 2 oxygen. Okay. These are the two reactants. Okay. And then it produced carbon dioxide and then water. H two molecules of H2O. Okay, and then the enthalpy of reaction is negative 890.4 kilojoule. Okay, so but if it will be multiplied by 2, so open and close parentheses, so all of them, each of the compound in the thermochemical equation will be multiplied by 2. So the CH4 will have 2 molecules. The oxygen will be 4 because it's already have 2 here in the original equation. And then it's also the carbon dioxide. It will have 2 molecules of carbon dioxide. And then the H2O will be 4 molecules. Okay. But if it will be multiplied by 1/2, so it will be reduced by half. All right. So um, just to study this picture for you to have more understanding about this. All right. So we have here an enthalpy of a reaction as negative. So it means that this is an example of exothermic reaction. Okay. The heat has been released by to the surroundings. Okay. So let's continue. Excuse me. All right. Next. So um, I have here, it says here that remember the symbols of the given equation that will be used in the problem solving. So before you proceed in solving this um, problem, a given problem, you need to familiarize this equation. It's like very complicated, no? Pero when you study this, you will be amazed because it is just easy, no? So let's proceed. Ayan. So this is the definition on the left side, and then the symbol is on the right side of the table. So we have here standard, ayan, standard molar enthalpy of formation. So for the symbol is this delta H with Celsius, I mean degree, and then F. It means that enthalpy of formation. Okay, so this one is constant. You will be uh, getting the value of that certain compound later in the table given. Okay, so you don't have to think what is the example for this one. What is the molar enthalpy formation of carbon dioxide? Okay, it is already given. It is constant in the table. Okay, it's like um, the boiling point of the water is 100 degrees Celsius. So it's constant. So the value of each compound in the chemical reaction when it comes to standard molar enthalpy of formation is also constant. Okay, so it will not be difficult for you to find the value of each compound in a given thermochemical equation. Okay, so you just have to familiarize this symbol or equation. Okay, so when you see this symbol delta H degree sub F, so it means that standard molar enthalpy of formation. Okay, and then next we have a standard enthalpy of reaction. Okay, so reaction. So when we say standard enthalpy of reaction, this is the combination of the products and the reactants. Okay, so we have delta H degrees. Okay, degree Rxn. Okay, so standard enthalpy of reaction. Okay, so for the next one, this is the um, sample, okay, or illustration for the chemical equation. So we have small a, letter A, and then capital A, and then small b, and then capital B. So these two letters, A and B, small and capital, this is the reactants. Okay, the reactants. And then small C and D, and then capital C and D will be for the products. Okay, so be remember that the small letters A, B, C, and D are the coefficients of the substances of A, B, C, D, or substances of the capital A, B, C, D. All right. So if I have here carbon dioxide, or the letter A is the carbon dioxide, and then I have put here 2 on the small letter A. So example, so we have here 2, and then I have here carbon, let's just try carbon monoxide, so that you can write it easily. So if I have here 2 carbon monoxide, it means that the coefficient of the carbon monoxide is 2. Okay, and then we have the compound carbon monoxide. So you just have to look at the table uh, of your book on page 65 for the standard molar enthalpy of formation of carbon monoxide. Okay, so if I will look at the table on page 65, the we can say that this standard molar enthalpy of formation is, you will find there is specific heat. Okay, the specific heat of carbon monoxide is negative 110.5. Okay, so we will have an example later, don't worry. Okay, let's continue. All right, so I mentioned a while ago that yeah, before we proceed to that, um, you have to familiarize also this one. It's a little bit complicated, but I believe that you can do this. All right. So this one, it's like a big letter in it. It's the symbol. It's like, but it symbolizes as the sum. Okay, sum, the total. Sum of the enthalpies of formation of the products. Okay. So this is the for you to get the value or the amount of the products. Okay, of the chemical equation. So we have here small letter C, okay? So that is the coefficient of that certain compound, okay? So just look at the equation later, chemical equation later, for the compound, for that compound, okay? And then you will be able to uh, get the value of that compound. At the same time, it's the same with the letter D. Okay, so the sum of the enthalpies of the formation of the products is, this is the symbol, ayan, equals C, coefficient of that compound, and then this one, the delta H, degrees, F, yung formation, okay, yung specific heat ng compound ng letter C. Okay? And then the letter D, it's also the coefficient of that compound. So if you will see that the compound has only one or there's no coefficient, so it means that it is equivalent to number one. So you don't have to put the number one because it's already it's automatic, no? Ayan. And then you will put here the name of that compound. Okay? Ayan. It's the same thing with the reactants. Okay? It's the same thing with the reactants. So the sum of the enthalpies of formation of the reactants. Ayan. So you just have to combine the specific heat of the letter A and then the letter B. Okay? So if if in the chemical reaction is, you will see in the reactants, you have oxygen plus hydrogen. So there you will find the specific of hydrogen, at the same time the specific heat of oxygen, and then you combine it, okay, together with the coefficients of these two elements or molecules. Okay, and then before you find the enthalpy, the difference, okay, the difference in the enthalpy of the reaction, okay, this one, the one that I have highlighted. Okay, so when you get the total of the sum of the enthalpies of formation of the products, and then the sum of the enthalpies of formation of the reactants, that's the time you will subtract them so that you can get the enthalpy of reaction, okay, or the standard enthalpy of reaction. Okay, so it's just easy. Yan. So let's have an example. Okay, so it says here that the table below has the constant value of the specific heat of the standard molar enthalpy of formation of a substance that will be used for the computation of the standard enthalpy of the reactions. All right, so yeah, so this is the value of the specific heat of a certain compound that you can find in the chemical equation or thermochemical equation. So we have here H2O in the liquid phase. So its specific heat is negative 285.8. So it will not change. It is constant. Okay. It's the same thing if you have nitrogen 2 in a gas phase. So there is no specific heat. Okay. What else? We have here carbon dioxide because these are the common compounds that you can encounter in chemical reactions. So carbon dioxide in gas form, we have negative the specific heat or the standard enthalpy of formation is the negative 393.5, okay, kilojoule per mole. What else? We have here, ayan, oxygen 2, what else? NH3 and then others, okay? Just in the chemical reaction, just get the present compound and then find their value using this table. Or if that compound is not present here in the table, you can research or you can search in the internet. Okay, because it is also a constant. But in your problem solving, I have already provided the specific heat or what we call the standard, what do we call that? Standard molar enthalpy of formation. All right. So let's proceed to our um, sample problem. Okay. Mm, all right. Let me check this one first. I think, yeah, let me check the continuation of this one. Okay, let me share once again my screen. This is the sample problem. Okay. And so in our sample problem, we have consider the combustion of ethanol to produce carbon dioxide and water. Okay. So the balance, so the first thing that you need to do is be sure that you have balanced the equation. But if it's already balanced, you can continue. Okay, so we have ethanol C sub 2 H sub 5 OH plus um, 3 molecules of oxygen 2. And then we have produced a product 2 molecules of carbon dioxide and then 3 molecules of H2O or water. Okay. And then we have here the sum of the enthalpy of the products, which is the carbon dioxide and then the water. Okay. So we have 2 coefficient for the carbon dioxide and then we have 3 coefficient for H2O. All right, so just put the value of that product to the equation of the sum of the enthalpy of the formation of the products. Okay, so that's why I have here 2. So it means there is a 2 coefficient for the carbon dioxide. Yan. And then 3 for the H2O. And then for you to get the sum of the enthalpy of the formation of the product, so you need to get the value of their specific heat that you can find in on the table given. Okay, so I said a while ago that the value of the specific heat, or the enthalpy of the formation of the product, is negative 393.5 kilojoule. And so 2 times negative 393.5 kilojoule plus 3 times negative 241.8 kilojoule. Okay, this is the specific heat, the value of the H2O in gas form. And then when we compute it, we have this answer, negative 1,512.4 kilojoule. So this is for the sum of the enthalpy of reaction of the products. Okay, and then for the reactants, we have the reactants of ethanol and then oxygen. Okay, so for ethanol, we don't have coefficient here, so it means that it has only one coefficient. Okay, and then here the oxygen, it has 3 coefficients. All right, so let's put it here. Ayan. So this is the value or the specific heat of ethanol, negative 277.7 kilojoule plus 3 times 0, because there is no specific heat for oxygen 2. Excuse me. All right, let's continue. And then the sum of these two, the products and the reactants, you will get their difference, so that um, we can get also the enthalpy of the reaction, or the standard enthalpy of the reaction. So we have here for the products negative 1,512.4 kilojoule. And then for the reactants, we have negative 277.7 kilojoule. And then we subtract them, and then we got negative 1,234.7 kilojoule. This is the standard enthalpy of the reaction of the ethanol plus oxygen, and it produced carbon dioxide and then water. Okay, so if the answer is negative to 1,234.7, it means this reaction is exothermic. Okay, because it has a negative sign. So this is the I hope that you get the procedure. Okay, for computing or solving the enthalpy of the reaction of these compounds. Okay, so let's begin. Let's continue. Another one is this contribution of Hess's law. Okay, you can read the 3 main steps or rules on your book, on page 66. Okay, this is just a simple one also. Hess's law states that the enthalpy of sum of a series of reactions is equal to the sum of the enthalpies of those two reactions. Okay, so for us to understand this better, let's have this example. Okay, so the thermochemical equation for the incomplete combustion of carbon into carbon monoxide is represented as. So we have here um, incomplete combustion. Okay, incomplete combustion. So what will we do so that we can apply the law of Hess or Hess's law? Okay, so um, in the using this one, this original equation, thermochemical equation, we have an overall process. We have two, okay, overall process, the number one and then the number two, okay. Uh, so we have here two steps, okay. We have here two steps. So the number one, for us to get this one, yung pinaka-original equation, we need to follow these two steps. Don't worry because this one is already given, okay? You just have to follow the law of Hess. Okay, so for the equation number one, we have um, carbon plus oxygen, and it produces two carbon monoxide, and then we have an enthalpy change, I mean enthalpy, enthalpy of reaction negative 393.5 kilojoule. And then using the step number two, we have two carbon monoxide plus oxygen 2 um, produces two carbon monoxide as well. Okay, and then we have an enthalpy of reaction of negative 566.0 kilojoule. Okay, so what will we do if we have these two steps? Okay, we will not be using the uh, the one that we did in the sample number one. Okay, but this one is I will say that this one is easier than the first one, because you will just have to remember three steps. Okay, so I said a while ago that if there is a need for the a chemical equation to be multiplied by 2, you need to do it. But if it's not, you don't have to. Okay, so for the first one, okay, for the first equation, chemical equation, um, why it has been multiplied by 2? My question is, why does it have to be multiplied by 2? Because in the original equation, okay, we need two carbon, okay, we need to have a two carbon atoms, okay, but we have on in the equation number one, we only have one carbon. So for us to have two carbons, we need to multiply the whole chemical equation of the number one uh, to multiply by 2, okay, to be multiplied by 2, and then also the enthalpy reaction. Okay, so we got two carbon atoms plus two molecules of oxygen 2, and then um, two carbon of I mean two carbon monoxide, okay, times 2. So we have the answer here. And so you can check also this one in your book. Okay. And then for the step number 2, you will just focus on the number 2 step. Okay. I mean, for the number 2 equation. Okay. Uh, the only thing that you will do in the equation number 2 is you will just have to reverse. Okay, reverse equation. So yung product, you will put it on the reactant side, and then yung reactant, you will put on the product side. Okay, reverse. And then the the sign will also be reversed. So if we have here negative, it will be positive. Okay, so let's have the step number 2. So this is the um, equation there at the above. So it has enthalpy of reaction, negative 566 kilojoule, and then I reverse it, okay? And then the sign turns to negative, to turns to positive. Okay, after that, after the step 1 and then the step 2, you proceed to step 3. It says solve for the manipulated equation to get the answer. If your answer is the same with the original equation given at the top. Okay, so let's check. So please look at the um, left side and then on the right side if there is a similar compound. So if there is a similarity or if they are similar, you will have to cancel them. And then the and then the rest, okay, the remaining ones will be written below. Okay, so the remaining are two carbons and then two oxygen. I mean, this oxygen 2 turns to one molecule because we have canceled the the other two. Okay, and so we have here two. We divided because on the left side we have four oxygen and then on the right side we have two oxygen, so we just divided them by two. Okay, so that's why you only have here negative uh, one molecule of oxygen 2. Okay, and the result is we have two molecules of carbon monoxide. And then the same thing with the enthalpy change, you need to compute them. Okay, so the difference is and then we have an answer negative 221.0 kilojoule. Okay, so that's the end of the explanation about the first problem solving is this one using this uh, equation and then formula, and then for the sample number 2 is we will be using the Hess's law. Okay, Hess's law, using this or applying these three steps. All right, so um, this will be your um, activity for the elaborate or extend. So if you have uh, more clarifications, you can just message me so that I can cater it. Okay, so I've already given here the specific heat of the compound that you can find in the balance equation. You just have to follow the sample that I have given you in this module. All right. So I hope that in some ways you have learned something, and if you have um, not completely comprehend this one, yeah, I'm willing to help you. Okay, because all of us are still learning. Okay, and if we are open for learning, the Lord will bless us. All right, so thank you very much. I hope that you will continue to really do your best for God's glory. So that's all. Thank you so much.